Classification of insecticides. Insecticides are chemicals used to control insects by killing them or preventing them from engaging in undesirable or destructive behaviors. Insecticides are pesticides used to kill insects. They include ovicides and larvicides used against insect eggs and larvae. Insecticides are agents of chemical or biological origin. Insecticides are pesticides that are formulated to kill, harm, repel, or mitigate one or more species of insect. Insecticides are used in agriculture, medicine industry, and by consumers. These are claimed to be a major factors behind the increase in the 20th century agricultural productivity. Paul Hermann Muller, a Swiss chemist, was awarded the Nobel Prize in Medicine for his life-saving discovery of DDT in 1939 as an insecticide useful in the control of malaria, yellow fever, and many other insect vector diseases. But I don't think this is a life-saving discovery. Some other problems are also raised. So this term I'm not that much, you know, agree into. Based on classification of insects, based on mode of entry, based on mode of action, based on chemical nature. So classification based on mode of entry: contact, touch, stomach, ingestion, fumigant, spiracles. Based on the mode of entry in the insecticides can be classified into contact insecticides, fumigants, insecticides, stomach insecticides, systemic insecticides. Contact insecticides: the toxicant which brings about death of the pest species by means of contact with the wax monolayer are getting absorbed onto the surface of the cuticle of the body, and also that penetrates into the body through the vulnerable sites like sutures, membranes, bases of CT and tracheal system on its body is said to be a contact poison. This is achieved by a brief application of the insecticide on the pest species or by the pest species crawling or passing over the treated surface having sufficient residues of the toxicant. Contact poisons are useful in the control of sucking insects and highly lipophilic. Contact poisons penetrate the skin of the pest and are used against those arthropods such as aphids that pierce the surface of a plant and suck out the juices. The contact insecticides can be divided into two main groups: naturally occurring compounds and synthetic organic ones. The naturally occurring contact insecticides include nicotine developed from tobacco, pyrethrum obtained from the flowers of chrysanthemum, and rotenol from the roots of Derris species and related plants, and oils from petroleum. So, though these compounds are originally derived mainly from plant extracts, the toxic agents of some of them, like pyrethrins, have been synthesized, synthetically modified, and created also. So, kill the insect by clogging spiracles and respiratory system and by acting as nerve or general tissue poison after entering into the blood through cuticle. Fumigant insecticides: mode of entry, spiracles and tracheae. Fumigants: the toxicant which is gaseous in its gaseous state penetrates insect through the tracheal system that kills the pest insect to be a fumigant. Fumigants are toxic compounds that enter the tracheal system of the insect through its spiracles or breathing openings. They are used mainly for killing insect pests of stored products, against insects found in animal sheds, against soil infesting grubs, and for fumigating nursery stock. They include such chemicals as hydrogen cyanide, carbon bisulfide, sulfur dioxide, naphthalene, nicotine, and methyl bromide. Fumigants are insecticides that become gases at temperature above 5 degrees Celsius. A good fumigant should be volatile enough, should penetrate deeply into the stored products, should be least toxic to human, should not be corrosive, should not deteriorate seed quality, and should not leave any toxic residue in foodstuffs. Stomach insecticides: mode of entry, stomach insecticides, stomach poison, Bt toxin. So first category was contact insecticides, direct contact, the toxicant which brings about death of the pest species by means of contact with the wax monolayer and getting absorbed onto the surface of the cuticle of the body, and also that penetrate into the body through the vulnerable sites like sutures, membranes, bases of CT and tracheal system on its body are said to be a contact poison. This is achieved by direct application of the insecticide on the pest species or by pest species crawling or passing over the treated surface having sufficient residue of the toxic end. Contact poisons are useful in the control of sucking insects and highly lipophilic. Contact poisons penetrate the skin of the pests and are used against those arthropods such as aphids that pierce the success of a plant and suck out of the juices. The contact insecticides can be divided into two main groups like naturally occurring compounds and synthetic organic ones. The naturally occurring contact insecticide include nicotine, developed from tobacco, pyrethrum obtained from flowers of chrysanthemum, and rotenone from the roots of Derris species and related plants and oils from petroleum. Although these compounds are originally derived mainly from plant extracts, the toxic agents of some of them, like pyrethrins, have been synthesized, kill the insect by clogging spiracles and respiratory system and by acting as nerve or general tissue poison after entering into the blood through cuticle. Then fumigants, insecticide, mode of entry, spiracle and tracheae. The toxin, which is in its gaseous state, penetrates insect through the tracheal system and kills the pest species is said to be a fumigant. Fumigants are toxic compounds that enter the tracheal system of the fumigant through its spiracles or breathing openings. They are used mainly for killing insect pests of stored products, against insects found in animal sheds, against soil infesting grubs, and for fumigating nursery stock. They include such chemicals such as hydrogen cyanide, carbon bisulfite, sulfur dioxide, naphthalene, nicotine, and methyl bromide. Fumigants are insecticides that become gases at temperature above 5 degrees Celsius. A good fumigant should be volatile enough, should penetrate deeply into the stored products, should be least toxic to humans, should not be corrosive, should not deteriorate seed quality, and should not leave any toxic residues in foodstuffs. Stomach poisons. Stomach poisons are toxic only if ingested through the mouth. They are most useful against those insects that have biting or chewing mouth parts, such as caterpillars, beetles, and grasshoppers. The chief stomach poisons are the arsenicals like Paris green, copper, acetoarsenite, lead arsenate, and calcium arsenate, and the fluorine compounds, among them sodium chloride and cryolite. Bacterial toxins are produced by certain soil microorganisms. Examples include Bacillus thuringiensis and Spinosymes. Beta toxins disrupt the digestive tract of caterpillars, so they are specific insecticides that must be eaten. They are applied as sprayers or dusts into the leaves and stems of plants eaten by the target insect. Stomach poisons have gradually been replaced by synthetic insecticides which are less dangerous to humans and other mammals. The insecticide applied on the leaves and other parts of the plant when ingested act in the digestive system of the insect and bring about kill. This type of poisoning is limited mainly to the chewing insect. This stomach poison should be palatable for the pest species and be able to bring about kill quickly. Sodium fluoride. Synthetic insecticides. Systemic insecticides. Yeah. Systemic insecticides are water soluble and are taken up by a plant and translocated to various plant parts in about lethal to insects which feed on them. This type of insecticide is introduced into the soil for it to get absorbed by the plant roots. Once the insecticide enters the root, it moves to external areas such as leaves, fruits, twigs, etc. It forms a layer on the plant surface area and acts as a poison to any insect that comes to chew the plant. The chemicals can thus be found in every part of the plant, including the leaves, roots, stems, fruits, flowers, and even the pollen and nectar. They can kill insects directly on contact or through the ingestion of treated plant tissue. Systemic protection is long lasting than contact sprays, and it is particularly useful against root feeding insects and boring insects such as emerald ash borer that typically evade foliar pesticides. Systemic insecticides, after uptake, are distributed systemically throughout the whole plant. When insects feed on the plant, they ingest the insecticide. Systemic insecticides produced by transgene plants are called plant incorporated protectants. For instance, a gene that codes for a specific Bacillus thuringiensis biocidal protein was introduced into corn and other species. The plant manufactures the protein which kills the insect when consumed. System insecticides are most of the time recommended against sucking insect pests of different crops. Piercing sucking insects are killed more rapidly because they normally receive a greater insecticide dose than chewing insects feeding on the same plant. These insects are easy to use because these can be applied on any part of the plant and these then absorbed by the plant and become a part of the plant and moves by moves of all plants of the plant. Classification based on mode of action. Depending on the ways which toxicants act upon, wait a minute. So, systemic one, we need to read once again. Systemic insecticides are water soluble and are taken up by the plant and translocated to various plant parts in amount lethal to insects which feed on them. This type of insecticide is introduced into soil for it to get absorbed by the plant roots. Once the insecticide enters the root, it moves to external areas such as leaves, fruits, twigs, and it forms a layer on the plant surface area and acts as a poison to any insect that comes to chew the plant. The chemicals can thus be used in every part of the plant, including the leaves, roots, stems, fruits, flowers, and even the pollen and nectar. They can kill insects directly on contact or through the ingestion or of treated plant tissue. Systemic protection is long lasting than contact sprays, and it is particularly useful against root feeding insects and boring insects such as the emerald ash borer that typically evade foliar pesticides. Systemic insecticides after uptake are distributed systemically throughout the whole plant. When insects feed on the plant, they ingest the pesticide. Systemic insecticides produced by transgenic plants are called plant incorporated protectants. For instance, a gene that codes for a specific Bacillus thuringiensis biocidal protein was introduced into corn and other species. The plant manufactures the protein which kills the insect when consumed. System insecticides are most of the time recommended against sucking insect pests of different groups. Piercing sucking insects are killed more readily because they normally receive a greater insecticide dose than chewing insects feeding on the same plant. These insecticides are easy to use because they can be applied on any part of the plant, and then these are absorbed by the plant and become a part of plant and moves of all parts of the plant. Classification based on mode of action. Depending on the base by which toxicants act upon the system of an insect to bring about its death, they are grouped as follows: physical poison, protoplasmic poison, respiratory poison, nerve poison, poisons of more general nature and action. Physical poison, the toxicant which brings about kill of an insect by exerting a physical effect, is a physical poison. Heavy oils, tar oils, etc. cause the insect, particularly scale insects, to die of asphyxiation or by exclusion of air. Inert dusts affect a loss of body moisture by lacerating the epicuticle due to their abrasiveness as an aluminum oxide, or absorb moisture from the body due to their hygroscopic nature in case of charcoal. Both the conditions may be found in certain dusts. The toxicant which brings about kill of an insect by exerting a physical effect is a physical poison. Heavy oils, tar oils, etc. cause the insect, particularly scale insect, to die of asphyxiation by exclusion of air. Inert dusts affect a loss of body moisture by lacerating the epicuticle due to their abrasiveness as in aluminum oxide, or absorb moisture from the body due to their hygroscopic nature as in charcoal. Both the conditions may be found in certain dusts. Then protoplasmic poison, a toxicant responsible for precipitation of protein, especially destruction of cellular protoplasm and midgut epithelium, is said to be a protoplasmic poison. Heavy metals such as mercury and copper, fatty acids, formaldehyde, ethylene oxide, nitrophenols, nitrocercosols, fluorine compounds, arsenic compounds, etc. come under this group. The respiration poison is chemical which blocks cellular respiration, as with the fumigants like hydrogen cyanide, carbon monoxide, etc. is said to be a respiratory poison. It combines with enzymes like cytochrome oxidase and other oxidases containing iron and thus inhibit their catalytic action. Nerve poison, a chemical associated with its solubility in tissue lipoid and functions actively by blocking acetylcholinesterase in insects and warm-blooded animals, is called a nerve poison. Examples are organophosphatic and carbamate insecticides, organochlorines, DDT, lindane, paradichlorobenzene, etc. Then botanic insecticides, pyrethrum and nicotine, poisons of more general nature and action. This category includes compounds which induce neurotoxic symptoms after some latent period. Chlordane, toxaphene, aldrin, and dieldrin. Those which have an immediate depressant action. Organic thiocyanate like thionate, and which are muscular depressants. Rotenone, Dryania, and phenothiazide. Thiazide. Classification based on chemical nature. The following is a broad classification of insecticides based on their chemical nature, like inorganic insecticides. Arsenicals, fluorine compounds, metallic salts and miscellaneous compounds. Then organic insecticides, oils and soaps, insecticides of plant origin, synthetic organic insecticide, fumigants or gaseous insecticides, hydrogen cyanide, carbon disulfide, ethylene dichloride, methyl bromide, phostotoxin. Fumigants or gaseous insecticides, hydrogen cyanide, carbon disulfide, ethylene dichloride, methyl bromide, and phostoxin, attractants and repellents. Inorganic insecticides, they are of the following types: arsenicals, lead acetate, calcium acetate, fluorine compounds, metallic salts and miscellaneous compounds. Arsenicals, lead arsenates, calcium arsenates. Lead arsenates, they are of two types: acid ortho arsenate, basic orthoarsenate. It adheres on foliage after spraying or dusting for a long time. It is also used as a poison bait after mixing with bran and used against beetles damaging potatoes and other vegetables. And calcium arsenate, it's cheaper and more toxic than lead arsenate and used against leaf-eating insects as a dust or spray and may be mixed with VHC, sulfur and cryolite. It is widely used against pests of cotton tomatoes and potatoes. Other arsenicals are sodium arsenate, copper arsenate, arsenous oxide, sodium arsenate, then zinc arsenate, magnesium arsenate, etc. They are the most used as poison baits. Fluorine compounds, stomach poison suitable for household pests in the form of baits. Common fluorine compounds: sodium fluorosilicate, sodium fluoride, barium fluorosilicate, and cryolite. And metallic salts and miscellaneous compounds, they can be grouped as stomach and contact insecticides. The stomach insecticides include thallium sulfate against ansis bait, mercury chloride and mercurous chloride against cabbage maggots and onion maggots, borax against housefly maggots, and boric acid against cockroaches, etc. Inorganic contact poisons include sulfur against trips and scale insects like lime sulfur, calcium pentasulfide, calcium tetrasulfide, calcium sulfide, etc. Organic insecticides, they are classified as follows: oils and soaps, insecticides of plant origin, nicotine, pyrethrum, rotenone, neem products, synthetic organic insecticides, the chlorinated hydrocarbons, organophosphorus compounds, the carbamates. Oils and soaps. In India, use of kerosene, diesel, crude oil, and pine oil and tire oils are used against the household and orchard pests, while cresol oil in case of forest pests. The diesel and other oils are also used in the control of pests of fisheries. They are used with soap as emulsifiers. They block the spiracles, penetrate the tissue, and alter body metabolism with inhibition in exchange of gases. Fish oil soaps and potash vegetable soaps are mixed with water to form an emulsion which acts as a perfect contact poison and spreads against aphids, scale insects, leafhoppers, sting bugs, mealybugs, etc. The soap, besides emulsifier, are also used as wetting agents, stabilizers, and spreaders for the insecticides of plant origin. Insecticides of plant origin, the extract of some plant structures are known to have competent insecticidal property and less toxicity to man. Vertebrates are negligible one to the plants. These are nicotine, pyrethrum, nitrotenoids, and allied synthetic compounds which are used at larger scale. Nicotine. It is extracted from the tobacco plant Nicotiana tabacum and Nicotiana rustica, mostly from the leaves. Nicotine sulfate is widely used in the form of 40% emulsion and it is a contact, stomach, and fumigant insecticide, mostly used against the aphids, jacids, and trips. Nicotinoids commonly contain pyridine ring. It is a highly basic nitrogen on the pyridine ring and it represents an unsaturated alpha position on the pyrimidine ring. Pyrethrum, rotenone, neem products, synthetic organic insecticides. The chlorinated hydrocarbons. Yeah, we were talking about the classification. Organic insecticides are classified into oils and soaps. Insecticides of plant origin, nicotine, pyrethrum, rotenone, neem products, synthetic organic insecticides. The chlorinated hydrocarbons, organophosphorus compounds. The carbamates, oils and soaps we are going to learn. In India, use of kerosene, diesel, crude oil, and pine oil and tar oils are used against the household and orchard pests, while creosote oil in case of forest pests. The diesel and other oils are also used in the control or pests of fisheries. They are used with soap as emulsifiers. They block the spiracles, penetrate the tissue, and alter body metabolism with inhibition in exchange of gases. So, in India, use of kerosene, diesel, crude oil, and pine oil and tar oils are used against the household and orchard pests, while creosote oil in case of forest pests. The diesel and other oils are also used in the control of pests of fisheries. They are used with soap as emulsifiers. They block the spiracles, penetrate the tissues, and alter body metabolism with inhibition in exchange of gases. Fish oil, soaps, and potash. Vegetable soaps are mixed with water to form an emulsion, which act as a perfect contact poison and spreads against aphids, scale insects, leafhoppers, sting bugs, mealybugs, etc. The soaps, besides the emulsifiers, are also used as wetting agents, stabilizers, and spreaders for the insecticides of plant origin. Insecticides of plant origin. The extract of some plant structures are known to be competitive insecticide property and less toxicity, competent toxicity insecticidal property and less toxicity to man, vertebrates, and negligible one to the plants. These are nicotine, pyrethrum, and rotenoids and allied synthetic compounds, and which are used at large scale. Nicotine is extracted from the tobacco plant Nicotiana tabacum and Nicotiana rustica, mostly from the leaves. Nicotine sulfate is widely used in the form of 40% emulsion, and it is a contact, stomach, and fumigant insecticide, mostly used against the aphids, jacids, and thrips. Nicotinoids commonly contain pyridine ring. It is a highly basic nitrogen on the pyridine ring, and it represents an unsaturated alpha position on the pyridine ring. Nicotine 1,1-methyl pyrrolide is the major insecticidal alkaloid, while other nicotinoids are the nornicotine and the anabase. Pyrethrum. It is extracted from the flowers of the plant chrysanthemum. It is extracted from the flowers of the plant chrysanthemum. The pyrethrum extract consists of six volatile esters, which are derived from cyclopropane carboxylic acids and are pyrethrin 1 and 2, cynarin 1 and 2, and jasmolin 1 and 2. It is a contact poison and used against the household pests of livestock, vegetables, and crops. Neem products. Neem seed oil and other neem products are potent insecticides. Then rotenone is extracted from the roots of the plant Derris elliptica. It is commonly used as fish poison and also used against the leaf cutting caterpillars. It is contact poison and available as a dust, vegetable powder, and emulsions. All plant insecticides are neurotoxicants and prevent mitochondrial respiration. Plant insecticides are neurotoxicants and prevent mitochondrial respiration. Rotenone. Then synthetic organic insecticides. Synthetic organic insecticides. There are three groups of SOI: the chlorinated hydrocarbons, organophosphorus compounds, and carbamates. The chlorinated hydrocarbons, their molecules consist of chlorine, hydrogen, carbon, and sometimes oxygen. They have long residual stability and are both stomach and contact poison. Commonly chlorinated hydrocarbons are DDT, dichlorodiphenyl trichloroethane, BHC, benzene hexachloride, aldrin, and fluoride. All are available as dust, vegetable powder, granules, and emulsifiers. They inhibit sodium, potassium, magnesium ATPase and block sodium potassium pump, causing blockage of impulse conduction and creating paralysis, leading to death. Then organophosphorus compounds. They are esters of phosphoric, orthioic acids. Their molecules consist of P, C, N, O, and S. Following well-known compounds are much popular due to their long residual value. PEPP tetraethyl pyrophosphate, parathion, malathion, demethone, methyl dimethone, phorate or thiamet, and diacephone and phosphamidone. They are basically almost liquids. Except first three, others are systemic compounds and are available in all formulations and used widely. They block synaptic transmission by inhibiting acetylcholinesterase ACHE, and finally inhibit impulse transmission resulting into tetanus, paralysis, etc., leading to death. The carbamates. They are esters of carbamic acid, and the first isolated compound, carbamyl, was an alkaloid extracted from the seeds of calabar bean, shown here. So they have contact and systemic action and act as an anti-cholinesterase agent. They widely used carbamates are the carbaryl and beigen. Then they widely used carbamates they have. Then fumigants or gaseous insecticides, hydrogen cyanide, carbon disulfide, ethylene dichloride, methyl bromide, photoxin. Gaseous poisons cause quick and effective death of insects are the fumigants. Some gases are poisonous to insects and other animals, which can be used as insecticides in order to control the insect pest of enclosed spaces like groceries, godowns, mills, factories, museums, ships, airtight chambers, greenhouses, etc. Infesting of stored food grains, household furniture, books and stationery, ornamental plants, etc. They are characterized by low molecular weight and representing the simple derivatives of the organic gases like methane, ethane and propane, etc. They kill the insects either by closing the spiracles or by exerting their toxic effect on the body tissues after entering through the tracheal system. Due to such peculiar mode of penetration, the fumigants are effective against all types of insects. They are deadly toxic to man and other animals. Hydrogen cyanide, HCN. Cyanogas. In 1783, it was discovered by Shelley and used first as a fumigant against the scale insect Aetheria purchasei in 1886 in USA. It is a colorless gas which can be readily be produced by mixing sulfuric acid and sodium cyanide. Hydrogen cyanide is produced. Beside gas, it can also be available in the form of dust and liquid. Liquid HCN can be stored in the iron cylinder under pressure while gets converted into a gas as soon as released outside into the air. HCN discs can also be readily used, which are prepared from the wood, paper pulp or clay, etc. It is miscible with water, alcohol and ether. Carbon disulfide. Its insecticidal nature was first reported in 1854 by the French chemist Guerreau. It is yellowish color having offensive odor. Which one? Carbon disulfide. It is highly inflammable and readily soluble in alcohol, ether and chloroform. It is widely used for the fumigation of nurseries around grains and potatoes. In stored grains and potatoes, it can also be used in soil fumigation. It is harmful to some plants, seeds and animals. Then ethylene chloride. So first one was carbon disulfide. The next ethylene dichloride. It was first developed by Cotton and Roark in 1927. It is a colorless liquid and miscible with organic solvents without having any adverse effect. It can remain stable in the association with water, alkalis and acids. It's highly inflammable and is commonly mixed with carbon tetrachloride. It is available in the market as EDCT. It is used against stored grain pests. It is harmless. Ethylene dichloride. It is used against stored grain pests. It is harmless to man and other mammals, plant products, and after an exposure to 24 to 72, it kills the insect slowly. EDCT is available in the form of liquid, which is volatile at the room temperature and so easy in handling, so as it can be applied by pouring it over clothes or a grain bag or grain bins. Methyl bromide. In 1932, it was reported to have insecticidal property by some scientists. It is a gas with good penetrating power at the room temperature. The liquid is colorless. The gas is soluble in most of the organic solvents and non-inflammable, and this can be used as a fire extinguisher. Which one? Methyl bromide. It is widely used for fumigation of warehouses, rice mills, dormitoria, and soil to destroy stored grain pests and nematodes. It is very cheap in comparison to other fumigants and non-explosive, with low water solubility, high penetrating quality, and low absorption in the oils and fats of the seeds. It is extensively used in India. It is very toxic to man and other animals. Then Phostoxin is available in the tablets which release gases of phosphine penetrating the food grains. Phosphine gases released from this. It is very effective against a variety of stored grain pests in all developmental stages. It can be used safely in granaries, dumps, oil bins, earthen bins, bits, bags, and melon stores. It is composed of pure aluminum phosphide powder, and after releasing gas, it changes in shape and yields a garlic smell for several days below 60 degrees Celsius. Then, attractants and repellents. These chemicals don't behave as poisons, and therefore they are incapable of killing the insects. On the other hand, they attract the sensory receptors and bring a sudden change in the behavior of the insects, like attraction or repulsion of the pest population at the site of application. The attractants and repellents are in fact the mechanical agents facilitating the mass collection of the insects for their mechanical destruction, such as hand picking, etc. Attractants, the chemicals that cause insects to make oriented movements towards their source, are called insect attractants. They influence both gustatory and olfactory receptors. Types of attractants: lure and kill. Pheromones, natural food lures, oviposition lures. Then poison baits. Pheromones are chemicals that are secreted into the external environment by an insect which elicit a specific reaction in the receiving insect of the same species. So in this type of attractant, pheromone, natural food lures, oviposition lures, poison baits, all these things are present. So pheromones are chemicals that are secreted into the external environment by an insect which elicit a specific reaction in the receiving insect of the same species. Use of the pheromone baited traps. Pheromone baited traps are placed at suitable points. When the insects have gathered in large number, they can be killed by insecticides. Mating disruption. Pheromones are used for suppressing mating by confusing male insects. With the disruption of mating, male eggs can be prevented, egg laying can be prevented, and thus the pest population level will be reduced. The natural food lure. These are the chemicals present in the plant and animal host that attract the pests of feeding. Examples: Aedes species, lactic acid plus carbon dioxide, then housefly, sugar and molasses, bark beetle, terpenes. The oviposition lure, chemicals that govern the selection of suitable site for oviposition by the adult female. Example: methyl acetophenone attracts rice stem borer for oviposition. In poison baits, these are the mixtures of food lure and insecticides. Example: moistened bran base, molasses and insecticides for biting insects, phosphorus plus sugar syrup for cockroaches, thallus phosphate and peanut butter for meat loving ants. Repellent substances whose stimuli elicit avoiding reactions or chemicals that prevent insect damage to plants or animals by rendering them unattractive and palatable. Offensive are called repellents. There are two types of repellents: physical repellent, chemical repellent. Physical repellent, these include waxes of leaf surface and oils on different parts to repel various insects. In chemical repellents, these are the chemicals that affect olfactory or gustatory receptors of insects and could be of plant origin or synthetic. The important repellents of plant origin are oil of citronella, which is used as mosquito repellent, and pyrethrum, which is used as a repellent against the blood-sucking insects. The examples of synthetic repellents include benzoate for mites and borax mixture for foliage feeders. Next topic: insecticide synergists, also called activator or adjuvant. The term synergist is derived from the Greek word synergos, meaning together. Synergists are chemicals which have little or no insecticidal activity of their own, but when added to an insecticide, enhances its toxicity manifold. The enhanced toxicity is greater than the sum of the toxicities of the two components separately to more than additive total of the two taken together. This phenomenon was discovered in 1938 is known as synergism, and the substance producing it a synergist, a substance that has the opposite effect that reduces the toxicity of an insecticide is called an antagonist. Examples of synergists. Synergists are known for only some insecticides like pyrethrins or retinoids and contain organophosphates. The best and its first non-synergists are those related to pyrethrins. Pyrethroid synergists fall into three classes of chemicals like methylene dioxyphenyl compounds such as sesame derived from the oil of Sesame indicum, piperine obtained from black pepper, piperonyl, cycloine or cyclohexanone good for field crop insecticide, piperoil, butoxide good for livestock insecticide, piperoilamides, propylisome and furangiamide. N-substituted amides like N-isobutyl acetylamide or N930, terpene derivatives like phenite, terpene, diacetate and pine oil. Some of the synergists are also synergists for organophosphates. For example, pyrenoyl cycloine sulfide, pyrenoyl butoxide, pyrenoyl isome are good synergist for, and piperonyl butoxide and sulfoxide for diaxion. Pseudo synergism. Certain substances increase the efficiency, not the toxicity of pyrethrins by stabilizing the droplet size of their sprays and thus ensuring better and persistent contact with the insect body, achieving a better rate of killing. They are referred to as a pseudosynergist. Lubricating oils and oil part of the sesame and pine oils, etc. For example. And mode of action of synergists. The mode of action of synergists has not been clearly understood. Three possible mechanisms are suggested. Synergists may produce two types of effect. They activate enzyme system, which then enhance the toxicity of the insecticide. This is a slow process taking a long time to operate and therefore not useful for synergism. Non-inductive effects are those in which synergists inhibit the enzymes that toxicity the insecticide and thus enhance the killing power of the latter. Synergists may improve penetration of the insecticide through the insect cuticle and the nervous system. This is indicated by the fact that synergism occurs only when application of the synergist precedes that of the insecticide. If the synergist is applied later than the insecticide, no synergism is seen, and synergists may be protecting the insecticide from. Wait a minute. First is enzyme production. For that mechanism, two types of effect. They activate enzyme system which then enhance the toxicity of the insecticide. It is a slow process taking a long time to operate and therefore not useful for synergism. Non-inductive effects are those in which synergists inhibit the enzyme that toxicity the insecticide and thus enhance the killing power of the latter. Synergists may improve penetration of the insecticide through the insect cuticle and the nerve system. This is indicated by the fact that synergism occurs only when the application of the synergist precedes that of the insecticide. If the synergist is applied later than the insecticide, no synergism is seen, and synergists may be protecting the insecticide from withering effects, thereby increasing the residual action and thus the amount of kill. Penetration improving enzyme production. Next, withering effects, protecting the insecticide from withering effects. Some common mixed formulations in use in India are methyl parathione plus DDT, toxaphene plus DD1, carbaryl plus gamma BHC, methyl parathione plus carbaryl and pyrocan.